Hello my dear students. Today we are going to discuss about informed search techniques. We have already seen uninformed search techniques or blind search technique in which we will not be given with any background information which will help us to reach the goal easily. So in that methods we have used the order of searching, whether it is a breadth-wise order or a depth-wise order. So in this technique we are using some background information, and that background information or a function or a hint which will lead us to the solution easily is called the heuristic. Okay, so heuristic, it is also called heuristic search, and sometimes in the question paper we have seen that as admissible heuristics. So you can expect any of these three terms in your question paper. Okay, so I've already told you heuristic is a technique which makes our search process or search algorithm more efficient. That means it gives a hint, maybe a cost or maybe a heuristic function or something like that, and that hint will help us to find the goal node easily. We are searching a tree of data, and while searching that tree of data, a background information about the cost or the optimum result will help us to reach the goal fast. So this makes the algorithm more effective, more efficient, more optimal. Okay, so heuristic is a problem specific knowledge that decreases the expected search effort, and it is not always working accurately. That means we cannot guarantee that this method or this concept will always give the correct result, but in most of the cases it does. And it works by searching or using some functions that estimate the cost of the current state to the goal state. Okay, and that is performing some functions from some calculations like that, and leading to the result. After all, the purpose of a heuristic function is to guide us or guide the search process in most profitable way. That means it will lead to a least cost distance or lead to a least cost path to the goal state. Okay, so generally the term heuristic is used for an advice which help us to find the goal. So for example, in the case of traveling salesman problem, we have already studied about that. In that case, we are using some cost values or some heuristic values, and these values are being used to calculate the nearest neighbor. That's it. So that is a value or an integer value or a data which help us to find the solution. That's it. So heuristic is a method that provide a better guess about the correct choice to be made. Okay. So there are different examples for informed search strategies. Like we are discussing the algorithms of best first search, hill climbing, A-star search, simulated annealing, and we are discussing these four concepts here. Now we are moving on to the first algorithm in the category of informed search, that is best first search. And this algorithm, simply if we say about it, it actually resembles the BFS method. Best first method is actually resembling breadth first method. That means we are implementing this technique by using Q, and what the simple difference is that here each node will be assigned with a cost value, and some calculations are made or some guesses are made with respect to these cost values, and the procedure is same. Okay, only the extra thing that we are using here is the cost, the node cost, and this algorithm is also called a greedy algorithm in the class of searching, because they quickly attack most of the desirable paths as soon as it is heuristic weight becomes the most desirable. That means this algorithm works with respect to the cost. It takes the node with the minimum cost to the goal node. It will be more clear when we are discussing the examples. First of all, we will see the concept. Okay, So first we are traversing the root node. Just rewind the algorithm or the concept of breadth first search. We have mentioned the same thing, traverse the root node. So we are taking the root node and checking whether this root node is the goal node. Okay, and if it is not, then what we are doing is traverse the neighbors of the root node, right? Then we are doing what? Traverse the neighbors of the root node. This is what is happening in the breadth first concept. But here the traversal is occurring with respect to the concept of coast. That's the only difference. So see the step 2. Traverse any neighbor of the root node that is maintaining a least distance from the root node and insert them in the ascending order into the queue. This is what is the difference. Okay, so in BFS, that means in breadth first search, what we have done is we have randomly inserted the child nodes or the neighbors of the root node to the queue in any order. There was not a predefined order, but here we are inserting the elements in their ascending order of the path coast. That's the difference. Okay, and again traverse the neighbors of the root node, perform the same thing. Okay, and this process will continue until we are getting the goal node. Okay, so let's move on to the algorithm. Before moving on to the algorithm, I will show you the implementation. See, this is a data tree, or it's a tree of data. We have a root node A and the goal node is B. Okay, the coast value of the goal will always be is equal to 0 because this coast refers to the coast of the node to the goal. That means that's why this is 0, because this is the goal. So the cost of reaching from P to P will be always equal to 0. So seeing from the root to the goal, each node will be assigned with an integer value, and that integer value is actually the path coast to the goal node. I think it's clear. So while implementing this, what is the difference between breadth first search and best first search? In breadth first method, we have inserted A into the queue, okay, and we have searched whether A is equal to goal node. No. Then we have inserted B, C, D, E to the queue, right? In any order, whether it is in B, C, D, E or E, D, C, B. In any order, we can insert these elements to the queue. Okay, and the traversal occurs as in the order as A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So only the two nodes which exempt from these searches Q and R. Okay, all the other nodes are being traversed to find the goal node. Fine. In the best first method, after traversing A and finding that it is not the goal node, what we are doing is insert the elements B, C, D, E in the ascending order of the path coast. That means D will be going first, okay, then we'll insert E, then we'll insert C, then at last B. So of course we will be traversing D first in this queue, and after getting D, we'll think about the child nodes of D, right? Then we'll think about the child nodes of those node which is having the lowest cost as the neighbor of D, that will be J, and going on to the procedure. This is the concept. So we are implementing this by using a queue, and first we are inserting element A, that is the root node. So we have inserted A to the queue, okay, and A is the friend, A is not the goal. What we will do next? We will remove A and insert the neighbors of the A, right? So see this. It's very simple. A is not the goal node, so remove A and find the neighbors of A. Which are the neighbors of A? B, C, D and E. Compute the path cost and insert them to the queue in the ascending order of the path coast. So I have found the, what we say, first for easy implementation or for writing, we can just insert them in any order first. Okay, so B, C, D, E, we are entering it into the queue, then we are processing the queue and reordering it. That will be better for understanding. Okay, so first, as in the breadth first method, you can insert B, C, D, E, and for ease of writing, you just write the cost on above the blocks, and then what we have to do is expand it, compute the estimated goal distance for each child, place the children in the queue in the ascending order of the goal distance. This is what mentioned in the algorithm. So after inserting this, you have to reorder the queue. Okay, so in the previous examples, each implementation step holded a single diagram, and here we are using two. First we are inserting it, then we are reordering it. That will be better. Okay, in the coming steps you will understand it better. So first, as in the breadth first method, we have inserted B, C, D, E, and we have wrote the cost above the blocks. Then we have reordered as 21 first, 23 second, 25 third, and 27 fourth. Then now the friend is D, right? D is the friend node and D is not the goal node. What we have to do now? Insert the neighbors of D. Okay, that we are going to do next. As D is not the goal, remove D. So we have removed D. Find neighbors of D. Which are the neighbors of D? J and K. See the algorithm here. Neighbors of the D are J and K. So we have removed D and inserted J and K. See. And write the cost of that blocks as well. So we have 23, 25, 27, 5, 7. Whether it is in ascending order? No. This 3 blocks were in ascending order and these 2 blocks are in ascending order, but overall in the queue it is not in the ascending order of the cost. So again, after inserting J and K, we will reorder the queue again. What happens? J comes first, K second, E third, C fourth, and B fifth. And optimally here we have J as the friend. So check whether J is the goal node. No. So J is the friend, J is not the goal. What we have to do? Remove J. Remove J and insert whom? The children of J. See what happens. So we have removed J. K, E, C, B are there. See, K, E, C, B are there. And we are inserting whom? The child nodes of J. Okay, the neighbors of J. As J is not the goal, remove J. Find the neighbors of J. O, P and Q. We have inserted O, P and Q. Again we have wrote the, what we say, cost. Okay, and after inserting them we are reordering the queue with respect to the path cost, and we will get P on the top, and sorry, as the friend. So P is the friend. Whether P is the goal? Yes, P is the goal node with the cost value 0, and now we'll stop traversing and return a success value that we have got the element that we have searched. Now see the algorithm. Okay, so place a starting node or root node into the queue. We have done. We have placed A to the queue. If queue is empty, then stop and return failure. We haven't gone through this step 2. And in step 3, what happens is, if the first element of the queue is our goal node, then stop and return success. And if step 2 and 3 is not correct, what happens? Okay, if the element on the queue as the friend is not the goal node, what we have to do? Remove the first element from the queue, expand it, and compute the estimated goal distance for each child nodes or the neighbors. Place the children in the queue in the ascending order of the goal distance. I think now it's clear to you. Go to step 3 again, and this procedure is going on until we are getting the result. This is the algorithm. Okay, so what are the merits or advantages of best first concept? Because it is more what we say, easy or more efficient while compared to breadth first and depth first concepts, and the time complexity of best first search is much less when compared to those two techniques. And this allows us to switch between the path by gaining the benefits of both BFS and DFS. So what is the disadvantage here is, in some examples it may cover more distances than our considerations. In some, in most of the cases this works best. Okay, now let's just compare the traversing or the searching of breadth first, depth first and best first. In breadth first concept, what happens is we are searching the nodes given in yellow are the nodes that is being traversed to reach the goal node. We are searching A, then B, C, D, E, then F, G, H, I, J. So many nodes are being traversed. And compared to depth first, which nodes are traversed? A, E, N, R, M, L, D, K, J, Q and then P. So half of the nodes are traversed. And what happens in best first? We are going to A, then D, then J and then P. So I think it's very clear through these diagrams that how optimal this search concept is. I think the idea is clear to you, and this is all about the best first search in AI. So if we work out this with 1 or 2 more examples, it will be super easy for you to understand, and it will be helpful while you are writing the exams. Hope you understand the concept. Thank you.